Hello, welcome to our new section of this course, Database in the Sandbox. In this section we'll learn about DDL statements and DML statements. Now we move on to the first video of this section that deals with DDL statements. In this video we'll see how to create a new database and new tables. DDL, or Data Definition Language statements, are a set of three simple but powerful and effective commands: create, alter, and drop. When you look at those words, they don't provide you with enough information about what they are capable of doing. In a nutshell, you can do these operations. First is the create statement, which will create anything from the server down to the database level of objects like database, tables, views, stored procedures, triggers, users, encryption keys, and so on. Next is alter. This gives you the option to modify any kind of object, including server configuration and the database itself. And the last is the drop statement. It's a dangerous but effective statement for deleting server and database level of objects. The database terminology for this action is dropping. Here's an example. The basic syntax for creating a new table. First, you need to use the create table keyword. Note that SQL is case sensitive. Then, you need to give the table name followed by column definition and list of parameters. Before we create some tables and other database objects, we need to set up our playground. I'm assuming that you have some basic knowledge about databases, tables, data types, and relational modeling. However, don't worry, I'll lead you all the way. First, connect to your SQL Server through the SQL CMD command line tool. For this, we need to first get the IP address of our machine. So, let's type sudo ifconfig, enter the password. Here you can see the IP address of my machine. Next, write SQL CMD -s192.168.6.233 -u SA and give the password. Now, we'll check how many databases we have on our instance by calling the sys.databasesCatalog view with the select statement. Via the query, select name from sys.databases, go. As you can see, for now, only the system databases are visible, but that's about to change. We have 4 rows affected. After this, enter the create statement in your SQL command to create a new database called University. Now that we've created a new database called University, we repeat the previous step to check how many databases we have. Run the query, select name from sys.databases. You can see that University is already added to the previous 4 rows. Now we'll call the catalog view, sys.databases files, to see some detailed information about our new database, which you can find at this website. Be careful, this view has a large number of attributes, and it will not be practical to see them all in the console. In my example, I'll just show a small number of them. Let's type use university and go. We now change the database context to University. Then we select physical name from sys.databases files. What we have here is the catalog view with a small number of attributes. Now we'll create some basic table structure for our University database. Nothing too complicated, but you'll get enough information about how SQL Server on Linux handles these requests. The idea is to practice a combination of DDL and DML statements in one project. From a database schema creation, to filling the database with some data, to changing the database structure, and finally, by creating database objects to access the data. The best way to explain this in practice is to create the tables inside our University database. So, we'll have 4 different tables as listed here. Students with basic personal data about students. The next one, educators with basic personal data about teaching staff. After that, courses, to store information about courses. And the last one, grades, which is the central point of our system data about students' evaluation grades. Our hypothetical system should look like this figure. This schema does not describe a real-life university system, but the basic concepts, such as column definitions, data types, and primary and foreign keys, are the same whether there are 4 tables or 100 tables. All the concepts are contained within these simple 4 tables or entities, and are the foundation of every university information system. So, let's start to write code for this database. First of all, if you're not connected already, connect to your SQL Server using the SQL CMD command line tool. Next, we tell the SQL Server that we want to work with the university database with the use keyword. In the next step, we create a students table and add a column with the name, student ID, which is a primary key for this table. Let's add 4 more columns. Last name, which can take 15 characters, and this cannot be null. Similarly, first name with 10 characters, not null. Email, which can have 15 characters. And phone, which can take 10 digits, and this field can have null values. Let's type Go. Now let's define a table for the education staff. We create the table Educators. Define Educator ID as the primary key. Similarly, define last name, first name, title, and email. So, now our table is defined. After this, we create the table for the courses. This table has the course ID as the primary key. We also need course name, which cannot be null, and active, which will take a Boolean value. Now, the last table will store students' grades and reference to other tables. So let's create the table with the name grades. Define grade ID as primary key. Here, student ID is a foreign key which refers to the students table. Similarly, course ID is a foreign key that refers to the courses table. Also, we have the educator ID as a foreign key referring to the educators table. Then, grade will take an integer value, and date column for date and time. So now we have the grades table ready for us. Now we call the catalogue view to see the list of newly created tables in the university database. Select name type descending. From sys.object, where type equals U, go. Superb. You can now see that we have 4 user tables created. In this video, we explored about DDL statements.